Hello everyone, welcome to the channel. In this video we're going to be looking at empirical and molecular formulas. We won't be doing any calculations in this video, we'll just be looking at the concepts, what it is, and at the end we're going to be converting from molecular formula to the empirical formula. So let's get into it. First things first, we're going to look at some definitions, and the empirical formula can be defined as the smallest whole number ratio of atoms in compounds. And this part over here, whole number ratio, is really all you need to know. The empirical formula is never going to tell you what a compound is. It won't tell you the properties of a compound. However, what it will tell you is the ratio of the constituting elements, like how those elements are arranged in what quantity. That ratio is what the empirical formula will tell you. On the other hand, the molecular formula is the actual number of atoms in a compound, and this is going to pertain to a specific compound. So, for example, as I did over here, in this instance, CH over here, this would be the empirical formula, while the molecular formula, the actual number of atoms in a compound, are going to be these two over here. So in this case, you can have this empirical formula is going to have multiple molecular formulas, one being ethine, C2H2, which is something that's used in fruit preservation. And then over here, you can also have something called styrene, C8H8, which is used for the polymerization of styrene is used to make styrofoam, right? So what this means is that one empirical formula can have multiple molecular formulas. And you can think of a molecular formula as like the fingerprint. It kind of identifies a compound. I wrote that out here. It's pretty important. The molecular formula is unique to a compound, while the empirical formula is just a ratio. So each empirical formula can have multiple molecular formulas. All right, so I'm just going to go over how we can convert kind of from the molecular formula to the empirical formula, right? So one way you can look at it, and I did the example of styrene here at the bottom, you have C8H8, and you can kind of look at it in ratios, right? So this goes back to like fractions and math and everything. So one way to look at this is like you have 8 carbons per every 8 hydrogens, right? And you want to simplify it to the smallest whole number ratio. Well, going back to math class, you know that 8 and 8, you can divide both parts of this quote-unquote fraction as ratio by 8. So if I were to divide it by 8, you're going to get C over H. Or if you write that as chemically, you can get this empirical formula, as we did over here. So you kind of want to look at it from a fraction sense as pertaining to these subscripts, how you can get them to the lowest ratio possible, right? And you have to apply whatever you divide to both of the subscripts, or however many they are. Let's look at a few practice problems. All right, and here I have a few. Feel free to pause the video, try to see if you can work them out on your own. I'll be going over them shortly. Here we have a compound that has 4 carbons and 10 hydrogens, so we can write it out as like a fraction almost again. So you can get like 4 carbons per every 10 hydrogens. It's a good way of looking at it. So you want to simplify this fraction. All right, you know that 2 divides evenly into both, so you get 2 carbons per every 5 hydrogens. And then if you write that out chemically, it's going to look like C2H5. Right? And then from here, you know that there's not going to be a number that's going to divide into 2 and 5 evenly so that you have a whole number as an answer. So this is just going to be the simplest formula possible. This is going to be the empirical formula, right? All right, so for the next one here. This one might trip you up because it's not divisible by 2, but it is by 3. Both of these numbers are divisible by 3. So what you can do is divide both sides by 3. You can get NO2 as the empirical formula, right? And that's just how you have to look at it, right? You kind of like fractions. After a while, you're not going to have to draw them out or anything. You kind of just do it mentally like that. All right, for this one, you have 8 carbons and 18 hydrogens. So obviously, the first thing you can see is that they're both divisible by 2, right? So if you go C4H9, that's what it would look like if they were both divisible by 2. And 4 and 9 actually don't have any numbers that if you divide into will produce whole numbers. So this is going to be the simplest formula. So this is going to be the empirical formula. And then finally, this one's a bit of a trick question. You have C2O5, which is going to be C2O5, which is going to be it's already in its lowest state, So that's just going to be C2O5 because no number is going to divide into 2 and 5 evenly, so that it produces a whole number. So this compound is already in its empirical formula, right? So it's already in its empirical formula. You cannot go you can't simplify it further. All right, so in this video, we looked at the empirical formula, empirical and molecular formulas, definitions. We looked at how you can go from the molecular formula to the empirical formula. And in future videos, we'll look at practice problems with numbers and everything. We'll go from the percent composition to the empirical formula and from the empirical formula to the molecular formula. So hopefully you enjoyed the video. If you found it helpful, please click the like button, consider subscribing to the channel, and hopefully we see you guys next time.